The next point I want to talk about is about failure. When you're truly designing systems, be it like a fighter plane or in airlines, something where something is so valuable that you just have to have a lot of redundancy for that system, is that they all designed for failure. They're all designing for, oh, if this is going to fail, here's how I'm going to, here's the other system that's going to kick in. And that is a kind of like a very important aspect of it. And that is what this monitoring is about, is one of those things. And then the other one is in the code, in the data processing to rerun the process. So there's a term that's used in data engineering a lot called idempotency. That just means like when you're running a particular pipeline to read data from one source, process it, and then write it to the other source. And somewhere in between, something fails, the network drops, and so it just doesn't finish, or it's half baked or half done. That it's totally doesn't work for the end user. So when someone's reading that table, they're not seeing all the data. That's not a good sign. So what you do for idempotency is you make sure that that user who is looking at the data from the data set's ultimate product that you built in the end is actually, it's not pointing to the data that you're writing to, it's pointing to something that's completely finished. So that helps you to rerun them. And also rerunability means doesn't mean to rewrite and rerun everything that took the first half hour to finish in the pipeline and suddenly broke. So you had to wait for another half an hour. No. So what it means is to process it in such a way that it catches up from where it left off. That is the beauty of idempotency. The code may decide like, okay, it just makes sense and it's faster to just recreate that thing again because it just took a few seconds to do it. Sometimes if it's taking a longer period of time in the code, it can determine like, okay, now this part of the pipeline, took a while to produce. And so for this code path of the pipeline, I'm going to make sure that I'm just going to catch up from where it left off. And so what you do is you query the data that has already been produced and you gather some information and some metadata and make a determination from where you have to continue on. And that is idempotency, and it's a very important topic. We'll cover that. I'll also show you some important things like in the code, for instance, this one is producing some events. And here I'm looking at some of the stats of those events. Like, for example, I'm looking at, these are 3 queries producing 3 data sets. You can see that the put latency, this is something that I'm capturing and I'm writing it down into a table in this case, but here I'm also outputting it to a standard output. So you can see that total number of events that I process is 10 million events. And out of that 10 million events, the max time that it took in milliseconds was about 2000 milliseconds. It comes to about 2 seconds for the writes on my local single disk AIStor cluster. And the mean is about 56 milliseconds, which is pretty low. And you can see the P95 is only 17 milliseconds. That means like 95% of the events finished in 17 milliseconds. And then there was 1 or 2 that took a while. So that's kind of like some of the information that I'm storing so that I can keep track of it. So when we talk about 10x scale, design for 10x, you want to write your code so you have a profiler that you can profile things better to produce this type of information on the fly as it's processing them. And also I want to show you, so these things are running on my local. I'll really have another segment that I really talk about the system, don't focus too much on that one. But I just wanted to show you some of the charts that come out from monitoring the AIStor cluster. So this is the default Grafana that actually gets all the data I need. It's coming from Prometheus, and there are some commands that Prometheus runs on the AIStor cluster to get the stats. It uses that, queues that up, and sends it over to Grafana. And Grafana has got these dashboards, which are these JSON dashboards that kind of understand and just build this. This is how it's built. I didn't do this from scratch. It is all the JSON that comes with AIStor docs. Okay. So here I'm looking at things for the last 3 hours, for instance, of whatever I processed, and you can see it talks about the object size and how it's distributed, the version distribution of those objects, total request rates, and you can see, look at the different types of puts and get buckets and other calls that has been made. So this is the idea I wanted to share here, is that it's about the monitoring and observability in order for you to know how your system is doing, because at the end of the day, failure is inevitable. And as a result, you want to make sure that your system is resilient and robust and running all the time. And in case it fails, something happens, breaks down, you're able to just rerun your system from where it left off. And so it'll know exactly what's going on. So in this case, I think data was coming through to Kafka and it processed all of those events. But sometimes when you rerun this, you can see that it starts off from 0, and then the message counter goes to 10 million later on. And at some point, if something breaks, it stops. And if the Kafka cluster is up, you can rerun your job from where it left off. And if you track all of this information, then you know from where you're supposed to continue. And that's the way you want to write your code. That's one main point about setting that mindset about thinking about your system as a potential failure, where it could fail and things like that, so that you could design your system so that you can bring those things online and running in no time.